Today our lesson will be the cross product of geometric vectors. We have seen dot product, the result would be a scalar quantity. For cross product A cross B, it means that A cross B, the cross product will be perpendicular to both vectors A and B. So this is perpendicular to both vectors A and B. So this is only in 3 dimensions. Cross product is only in 3 dimensions. We don't have cross product in 2 dimensions. Therefore, if I have a vector B and a vector A cross B, if this is the angle between the two vectors, A cross B is going this way here. When it goes to counterclockwise, that means the vector, the third vector perpendicular to both of them, gets out of the paper, we say, or goes up. So this is A cross B. This is A cross B. This is counterclockwise, going this way here, so it becomes A cross B. If this was B cross A, going this way here, clockwise, B cross A, that means it's going inside, so it goes down here, so this is B cross A. They are not the same, they are in opposite direction, A cross B and B cross A. They are in opposite direction. So in geometric vectors, A cross B means we can visualize it with the right hand rule in physics or in calculus. A cross B, this will be, the magnitude of this will be A and then B sine of the angle between them. So this is a magnitude and this is a geometric vectors. The direction is always A cross B. So let's see, typical application for cross product would be like torque. Torque is always, torque is always a turning point. So turning effect is a torque. So what's turning effect? Turning effect will be, we have the radius R and force. The magnitude of this will be the magnitude of R, the magnitude of force, times sine of the angle between R and F. The angle between R and F. So what do we have here? So the vector, this is the R is a vector acting from the center, from the axis of rotation. So it will be like force, and this is coming from the center of the action here. This will be my R, and this is my force. The angle is always here in between. This is continuation of R between R and F. That will be the angle. So this is a magnitude. The magnitude is always absolute value. That is the torque. The torque is in joules or Newton times meter or joules. So we have another typical application would be area of parallelogram. Area of parallelogram, which means that if I had if I have a parallelogram here, this is vector B, the base, and this is vector A, this is angle. We know that area of parallelogram is base times height. base times height, therefore let's find first what sine theta is. Sine theta is A H okay. Sine theta would be H over absolute value of A, which is a hypotenuse. Therefore, H is equal to absolute value of A times sine of theta. That's my H. So now the area of parallelogram will be base times height. Absolute value of B times height. Which means that B times A times sine theta, which is the same as A B sine theta. Therefore, area of parallelogram is always A cross B. Area is equal to magnitude of A cross B. That's area of parallelogram. Okay, so now let's see when we are given components. How do we find? There's the algebraic vectors. We are given algebraic vectors. So cross product of algebraic vectors. So if let's say I have vector A is equal to 1, 2, 3, vector B equal to 4, 5, 6. Now, if I want to find A cross B, A cross B, what I do is I write the first vector twice. 1, 2, 3. 1, 2, 3. And the second vector B, which is 4, 5, 6. 4, 5, 6. So attention, what I do is I take out the first column, I take out the last column. Okay, this is easier than the formula we have. We have a formula, but it's complicated, that formula, to study it. So what we do is the first one, 2 times 6, going down, 2 times 6 minus 5 times 3. That's the first coordinate. Then the next one is 3 times 4. Take away 6 times 1. Then the last one would be 1 times 5 minus 4 times 2. Then I simplify this, 12 minus 15, which is minus 3, minus 6, and minus 3. Well, this is positive 6, and minus 3. So a vector, this is a vector. A vector can be always simplified because a vector has direction. So I can make the vector shorter or longer by dividing by the same number, all the coordinates. If I divide them all by negative 3, I will get 1, negative 2, 1. It will be the same. I can leave it here or I can simplify it. It is the same vector. So this is what we do. So we have a formula, but this is better than the formula we have. Let's do more exercise of this one here. Okay, let's see. Given vector A is minus 2, 1, 4. And vector B is 3, 2, minus 1. First, find A cross B. No, let's make it would find a vector perpendicular to both vectors. What does it mean? A vector perpendicular to both vectors will be A cross B. A vector perpendicular to both vectors will be A cross B. So A cross B is perpendicular to A and perpendicular to B. So I have to find A cross B. So I write exactly the same way we did before, minus 2, 1, 4. I write it twice. I write 3, 2, minus 1, 3, 2, minus 1. I cross out the first column. I cross out the last column. Then I say 1 times minus 1, negative 1, take away. 2 times 4, 8. 4 times 3, 12. Negative 1 times negative 2 is positive 2. Okay, so then we have negative 2 times 2 is negative 4, minus 3 times 1 is 3. So the vectors are here, so this will be equal to negative 9, 10, negative 7. This is a vector perpendicular to both A and B. How do I check if my answer is right? If this vector is perpendicular to both of them, then check. The vectors negative 9, 10, negative 7, dot. The vector minus 2, 1, 4 must be equal to 0. Because perpendicular vectors, the dot product is 0. And the vector, the same thing, 3, negative 9, 10, minus 7, dot, 3, 2, 1 must be equal to 0. So, and then I check if my answer is right. So now, if I have these two vectors here, my second part of the question will be find area of parallelogram. The given ones are A and B, so we are given this is B and this is A. Find the area of the parallelogram. So the area of parallelogram will be magnitude of area will be the magnitude of A cross B, which is the magnitude of, we found the cross product, which is minus 9, 10, minus 7. This is a magnitude. To find the magnitude, what do we say? We do the square root of minus 9 square, 10 square, plus minus 7 square. So the magnitude will be the square root of that. Therefore, so now we say this will be square root of 149, 81, square root of 230. Therefore, this will be the area, which is unit square, whatever unit I have. That's the area of the parallelogram. Okay, another concept is if I have A cross B, in dot product it is commutative property, but here it will be minus of B cross A. It's a minus of B cross A. I can say minus B here, or I can put a bracket here. It doesn't matter what you have. Okay, so if I have now, like the same way, IJK, this is IJK. If I want to see I cross I, the angle between them is 0, and sine of 0 is 0. Therefore, I cross I will be 0 vector. J cross J will be 0 vector. K cross K will be 0 vector. But if I have I cross J I cross j, we are going clockwise, counterclockwise here. Therefore, the third vector is perpendicular to both of them. Therefore, I cross j will be k. If it was I cross k, I cross k is going this way here, clockwise, and clockwise we said is going down of the third vector perpendicular to both of them. Therefore, I cross k will be the third vector on the opposite sign, which is minus j. I can even check using components, this one here. This will be like 1, 0, 0, cross 0, 1, 1. If I cross product this one here, I will get 0 minus 1, 0, which is the same as minus 0, 1, 0, which is minus j. Okay, so these are the main things to understand about vectors as cross product. For example, very easily. So if I say this is vector A, this is vector B, the vectors must be tail to tail. Therefore, I extend the A, this becomes A, and this is the angle between the two vectors. So A cross B, what happens is going clockwise. Clockwise is down, so it will go down. So A cross B is down. If I have B and if I have A, then A cross B. What happens to A cross B? A cross B is counterclockwise, so we go out. Okay, so these are the main things for cross product. Cross product, the result is a vector. Sometimes it's called also vector product.